Hi everybody, it's Mr. Hand. This week we're looking at convex lenses. So earlier in their lesson you would have learned a little bit about refraction. Now what we're going to do is we're going to look at refraction when we are being very purposeful about the medium that the refraction is happening in. So the medium, like a lens, is designed very specifically with a very specific shape, very specific geometry in order to achieve a very specific type of refraction. So sometimes that can be used to make an image larger. Sometimes it can be used to bring an image into focus. It can be used in combination with other lenses to make far away things seem closer, okay, or smaller things seem larger. So a lens is any sort of thin, transparent medium that refracts light in a specific way. And there's two main types of lenses. There are converging lenses, okay, and they have this sort of convex shape to them, and there's diverging lenses. They sort of have like an hourglass shape to them. And the whole point of converging lenses is to bring light together, okay, and diverging lenses, the idea is to spread the light out. For converging lenses, we're going to focus on those for right now. Their job is to bring all the light to a focal point. Okay, so any incoming rays that are parallel will all meet at one spot called the focal point, and actually because it's a lens and the light can travel through it from either side, there's actually two focal points to a lens. So we're going to look at how to draw some ray diagrams now for these convex lenses or converging lenses. So the first ray is always going to be drawn parallel to the principal axis, and it'll pass through the lens and then it will refract down to the focal point on the other side. So this is very similar to when we were looking at mirrors, except instead of bouncing back to the focal point, it travels through to the focal point. So here's what it's going to look like. I'll grab my ruler, set it up here, and put it on top of my object, and I'm going to draw my first line in blue here. I'm just going to draw straight across until it hits the lens. And I use the center of the lens there just to keep things symmetrical. And that light will then refract down, it'll bend down through the focal point. So that's step one. In the second step, okay, the ray is going to be drawn through the center of the lens and continues on in that same direction to the other side. So let's have a look at that. So remember, my first ray looks something like this. This was my first ray. My second ray, what happened is I put my ruler on top of my object and I pass it right through sort of that target spot right in the middle of the lens, and it passes straight on through. So remember that the middle of a mirror, any mirror, curved mirror, flat mirror, acted like a plane mirror. Okay, the middle of a lens acts just like a flat piece of glass. The light passes straight on through to the other side. The third ray enters the lens going through the focal point and exits going parallel to the principal axis. So here's my first two rays. My third ray, again, is going to leave the top of my object. It's going to come down through the first focal point, hit the lens, and then from there, it will travel parallel now to the principal axis. And all three rays sort of meet up in the same spot. That new spot is where the image of my object is going to be. Now, this converging lens is a good example to look at for actually how the human eye works. So you may have heard me say this in other videos, that your eyeball actually has a converging lens like this, which allows you to sort of focus the light in the right location at the back of your eye so that the information can be sent by from your retina to your optic nerve to your brain, and that's how you perceive the world. So you don't actually see anything. Your eyes are, their job is to bring light in, focus it in a specific spot, and then your brain takes those electrical signals and creates images. That's why our brains are so easy to trick in terms of like optical illusions and things like that. So I'm going to just sort of draw right over top of this. Your eyeball has this lens at the front, and your eyeball kind of looks something like this. And so what it does is it actually focuses the images of the things that you're looking at onto the back of your eye. Now, some things are closer and some things are further. And so in order for your eye to do that, what has to happen is the lens itself actually has to change shape. So you have muscles here and here that help you to accomplish this. So they are constantly expanding and contracting that lens in order to bring things into focus for you. So you might have noticed this before, that when you're looking at something close up, your eyes might strain for a little bit to do it, but then you can bring it into focus. And then if you look away off into the distance, again, it might take a second for your eyes to focus, but that you can also bring that into focus as well. And you accomplish this by squeezing and contracting on that lens there. Let's have a look at some other ones. So here I've just kind of moved my object a little bit. We'll go back through our steps. So my first line goes straight across the top, down through the focal point. Okay, my second line goes right through the middle and passes right on through. And my third line goes down through the focal point and then straight across. And where they meet, that's where my image is going to be. And then I can draw it in there. Now here's another one where we move the object a little bit closer. Same idea, straight across the top, down through the focal point. And we can actually get away here with just even two lines. Finding out where they meet is good enough with two lines. We don't really need the third line. Where they meet, that's where we're going to draw in our image. Okay. The last example, we'll notice that the object that we're looking at is actually very close to the lens. So this is kind of like how a magnifying glass works. So magnifying glasses don't work unless you hold them close to the thing that you're looking at. Okay. And magnifying glasses can make things look bigger. Okay. So now I'll show you how that works. So we're going to draw our lines just like we did before. Straight across the top, down through the focal point. Okay, and then my other one is going to go straight through the middle, like this. And you'll notice, we've seen this before, where light rays don't meet. Okay, on the other side, what we actually have to do is we have to trace backwards. So I'm going to trace these back, like this on my diagram. Okay, and where they meet, that's where your eye will perceive, okay, the light to have come from. And so what this does is it actually allows you to enlarge an image. And so this is how magnifying glasses can make things seem so much bigger, okay, when you look at them through a magnifying glass. And so by using a variety of lenses and this sort of idea of making things larger, this is how we create telescopes, this is how we create microscopes, this is how we create binoculars. Okay, and we're able to achieve these sort of larger images. So this week I have you do a little bit of practice drawing some of these ray diagrams. Okay, if you have any questions about that, please feel free to contact me. Okay, the other thing to keep in mind when we're working on this with lenses is this idea, I mentioned like the microscope and the telescope before, but some other uses are also correcting vision. And so you'll see later on in the lesson how we can use converging and diverging lenses to correct vision for people who may have nearsightedness, farsightedness, astigmatism. Those are all things that we can correct using very specifically sculpted lenses. So if you have any questions about this week's material, please feel free to contact me.